Assalamualaikum and selamat sejahtera. So today I would like to talk about wave, 5.5 diffraction of wave. Alright, my name is Cikgu Suryati Yusof. I am from Sekolah Menengah Sains Mirza Pasha, Melaka. Okay, so I would like to teach you about topic 5.5 diffraction of wave. So what we are going to learn for this topic, first the student are able to describe diffraction of wave from the following aspect. First one is wavelength, frequency, speed and direction of propagation of wave. 5.2, determine the factors affecting diffraction of wave. 5.3, you have to draw a diagram to show the patterns of diffraction of water wave and the effect of diffraction of light wave. And lastly, we have to explain the application of diffraction of wave in daily life. Okay, in this topic, we are going to talk about three types of wave. That is the first one, water wave, light wave, and sound wave. Okay, so look at this picture, this beautiful picture. A diagram below shows two walls which are built near the shore. Two walls. So this is the first wall, second wall. Compare the pattern of the water wave before and after passing the gap between the two walls. What is the function of the walls? So this is the two walls that we are talking about just now. So this is the wave from the sea, and here is the wave after it passed through the two walls, or what we call the gaps. Okay, so this is another picture I took from the desktop of my computer. So this is the very big walls, natural walls. Okay, here is the sea wave. So here is the water will passing through the gap between the two walls, and so this is what we call the wave after passing the two walls. Okay, so let's look at a video showing the wave after the passing the gaps. So this is the shape of the waves. It's like circular. Notice that notice that this is the wave from the sea front. So it looks like the wave is quite high just now, but after passing the gap, it will become lower amplitude. Okay. So we are going to talk about diffraction of wave. So what is diffraction of wave? So diffraction of wave is a phenomena in which waves spread out or bend as they pass through a gap or around a small obstacle. So this is the gap between two walls. So this is the wave front. Okay, from point A, and you pass through, goes through the gap, and it will become spread out to become circular wave. Okay, right. So look at two type of wave, two size of wave. Sorry, two size of gaps. Right. The first one is smaller gap. Second one is larger gap. Okay.
When the gap size is approximately equal to the wavelength, the wave pattern after passing through the gap is circular. When the gap size is bigger than the wavelength, the wave pattern after passing through the gap is less circular.
Okay, now we continue to activity 1 to study the characteristic of the diffracted wave in the river tank. So this is a river tank. We fill the river tank with water. So we have two barriers to form gaps, right? So what we do is switch on the power pack, use a barrier to block the incident straight water wave, and observe the water wave beyond the barrier. Then send a straight water wave to pass through a gap. Observe the pattern of diffracted wave beyond the gap. Okay. So we have the straight is the dipper, a straight dipper, so which will produce a straight line ataupun this will produce a straight wave, a plane wave. Sorry, this will produce a plane wave which pass through the gap, and we will observe what is the pattern of the wave after passing the gap. So this is the result from the experiment. So plane wave passing through a smaller gap, so it will produce the wave has been spread out and form a wave like the shape of circular wave, right? So the before entering is a plane wave, after entering is the circular wave. Okay, show you. So plane wave produce circular wave. Okay, before diffraction, after diffraction. Okay, right. So you are asked to draw the diffracted waves. So this is for the wide gap, and this is for the narrow gap. So for the wide gap, so this is the wave after passing through a wide gap, and for the narrow gap after the wave after passing the narrow gap. So we can see that for the wide gap we have a plane wave, but it will bend a little bit at the edge. But for the narrow gap, we have a circular wave, right? Okay, question number 2. Compare the wavelength of the wave before and after passing the gap. So this is before lambda 1, this is after. So from the small gap, we can see that lambda 1 equals to lambda 2. Same with bigger gap, lambda 1 equals to lambda 2. So a conclusion, lambda before diffraction equals after diffraction. Next, what can you say about the direction of the wave after passing through the gap? Okay, so plane wave coming here in this direction, so it will spread out. Okay, in this direction. Okay, so we call it spread out. Same with the bigger gap, spread out. Okay. Now we conclude the characteristic of the wave after diffraction. Okay. So what can we say about the frequency? Equal, because we still use the same motor, vibrate with the same frequency. The wavelength is equal. Speed of wave, do you think is what? It should be equal because the depth of the ripple is equal. Therefore, the speed of the wave should be equal. Direction of the wave, we say that it's spread out. Amplitude, it will going to be decreased. Okay. Right. So now, why the amplitude of the diffracted wave decrease? So the answer is because the diffracted wave is spread out to wider area. So from here, it will be spread out to wider area. Okay, spread out wider area, and energy of the wave will reduce. So it will be reduced when we know that energy and amplitude is related together. So when energy reduce, therefore amplitude also will be reduced or will be decreased. So we have a smaller wave, right, after diffraction. Okay. Now, activity 2. We are going to study the factors which influence diffraction of water wave, right? So the first factor is the size of the gap. So describe the pattern of the wave after passing different size of gaps. So we have small gap, we have bigger gap. So this is a small gap, so the wave will become circular, and this one does not change much from the before. A plane wave, we have the edge bend a little bit at the edge, right? So this is a circular wave, plane and bend at the edge, and we call it diffraction obvious. Diffraction less obvious. Obvious means from plane wave it will change to circular wave. Okay. Now look at the next factor. What is the relationship between the shape of the diffracted wave with the size of the gap, right? So this is narrow, this is the wide gap, this is the narrow gap. So which one is more circular? So the narrow one. So it's a conclusion, the smaller the gap, the more circular the diffracted wave, the more obvious the diffracted wave. Okay, so the smaller the gap, the more circular of the diffracted wave. Okay, now describe the pattern of the wave with different wavelength after passing through the gap of the same size. Okay, so now this time we have the same gap, same size of gap, but we change the lambda of the wave. So how we change lambda? We change lambda by changing the frequency of the motor, right? So when the motors vibrate with low frequency, so it will have a small lambda. This is a bigger lambda, means high frequency, higher speed, right? Okay. So what can we say here is plane and bend at the edge. circular wave. So this the first one, lambda give you the diffraction less obvious, and because this is circular, it will become diffracted. The diffraction is more obvious. Okay, so look at the relationship. So what is the relationship between the shape of the diffracted wave with the size of the wavelength? We conclude that the bigger the wavelength or lambda, the more obvious. The more circular means the more obvious the diffracted wave. Okay. The longer the wavelength, the more circular the diffracted wave. Okay. So state the two factors that make the diffraction more obvious. So the first one is small gap, and the second one is long wavelength. The smaller the gap, the more circular the diffracted wave, the more obvious the diffracted wave. Same with the lambda, the bigger lambda, the longer the wavelength, the more circular the diffracted wave. Okay. So small gap and long wavelength. Okay, this is another conclusion from what we studied just now. So effects of diffraction of waves. So we have the first one, fixed wavelength. So we change the size of the gap. So wide gap, diffraction less obvious. Okay, less obvious means you have plane wave and band at the edge. Smaller gap, small gap, diffraction obvious by looking at the shape of the wave. Diffracted wave is more circular, right? Now the second factor is size, fixed size of the slit. The side of slit is constant. We change the wavelength. It's a short wavelength, long wavelength. So short wavelength, diffraction less obvious, plane and bend at the edge. And the long wavelength means you have a circular diffracted wave. Okay. Now activity 3. So we are going to study the diffraction of sound wave. Okay. So audible sound wave have wavelength in the range of 1.5 cm to about 50 meter. Light wave have wavelengths in the range of 4 to 7 times 10 to the minus 7 meter. A radio is placed nearby a corner of a wall. The radio is turned on. So this is the wall. So this is the radio. So this is the boy going to. He cannot see the radio, but he can hear the sound from the radio. The first question: compare the wavelength between sound wave and light wave. So we can get from this information. So what we have is a sound wave is bigger or larger, longer than the lambda for light wave. Okay. Lambda for sound wave larger than lambda for light wave. Okay. Next question: can you see the radio? What inference you can make about the diffraction of light wave? Yes, you cannot see the radio, so we conclude that light difficult to be diffracted. Can you hear the sound of the radio? What inference you can make about diffraction of sound wave? Yes, you can hear the sound, so sound can be diffracted. Now we have to relate between lambda and the effect of diffracted to explain why we can hear the sound from the radio over the wall, but you cannot see the radio. Okay. So the answer is sound waves are more easily diffracted because its wavelength is longer than the wavelength of light. Okay. So this is the reason. Okay, again, lambda for sound wave is bigger or longer than lambda for light wave. Therefore, sound wave are more easily diffracted. So we can hear the sign behind the wall. Okay. Now we move on to the next activity to study the diffraction of light wave. Okay. Direct the laser light ray through the single slit. Observe the pattern formed on the screen and draw the pattern. So here we use a laser pen, okay, red laser pen. So this is a single slit. Okay, and here is the screen. So we can see the diffracted light wave on the screen. Okay. So we are going to use the first one, a single narrow slit, and then a small pinhole. Okay. So this is the video to show the result of the experiment. Okay, we use single slit diffraction. So this is a red laser. Okay, red laser. so we use the single slit which can vary the width of the slit. Okay, so this is the laser pointer. So this is the diffracted wave that we can see on the screen. Okay. Okay. So we show you more clear. Okay. So this is the slit with increasing. So in the middle is very bright. Okay. And now you decrease the size of the slit and see what is happening. So slit with decreasing. Okay. Now we use a pinhole diffraction, shining a laser through a pinhole. So this is laser, so this is the pinhole. So what we can see on the screen. So we have to do the experiment in the dark. Yeah, this is the diffracted light wave. So beautiful, right? Okay, now let's conclude what we can see just now. So this is a narrow slit. So we have a bright light in the middle, and we have like straight bright alternate with the dark, bright dark alternately. Okay, but in the middle is very bright. So this for wider slits, and here is a small pinhole. Okay. So black and bright lines alternately, brighter in the middle. Okay, so this is what we can draw. Okay. If the question asks you to draw, this is the image of the diffracted light wave. Okay, so now I show you a very variable slit wave. Okay, so start with 0.02 millimeter, so increasing 0.04, 0.08, 0.16 millimeter. So we can see that single white slit, very bright light in the middle. Okay, very bright light in the middle. For single narrow slit, dark and bright lines alternately. Okay, this is for narrow slit. Sorry, this is for wider slit. So it's brighter in the middle. Okay. So this is a narrow slit, this is a wider slit. Okay. Okay, the experiment is repeated by using a pinhole camera. Okay, what happens to the light as it passes through the pinhole? Okay, so light will be diffracted. Okay, white light will be diffracted. Okay, now we move on to the last part, is to study the application of diffraction of water, light and sound wave in daily life. So we start with water wave. A pair of barriers is built to protect housing area near a beach. First question, compare the amplitude of the sea wave before and after passing through the wall opening. So amplitude will decrease. Okay. Now, by relating the size of the wave with the energy, explain how the erosion effect of the beach around the housing area can be reduced by the barriers. As we learned just now, when energy is low, the amplitude also will be low, right? So, the first part, build area with small opening so that diffraction can occur. So, the idea is we want to have the diffraction of sea wave after passing the two gaps, the two barriers from the gaps, right? So energy of the wave is spread out to a larger area after passing the gap, and will be reduced. Okay, amplitude of the wave will decrease. Okay, this is a example of one lagoon. Okay. Diffraction of water wave produce clump of water region suitable for docking of ship and water recreational activities. Okay, so this is the two barrier. This is the gap. Okay, so the seawater will pass through the gap. So this is what we call calm water region. So we have the purpose of water recreational activities or for docking of ships. Okay. Now we move on to the sound wave. An audio frequency generator connected to a speaker and placed near the corner of a wall. 3 students A, B, C are standing around the next corner. The generator and the speakers can produce sound at the same speed but with different frequency. When a high frequency sound is generated, only student C can hear the sound clearly. When a low frequency sound is generated, all the 3 students can hear the sound clearly. Explain the situation. Okay, so this is the radio. Okay, with the speaker. Okay, 3 students A, B, C. Okay, first we have to know the first one is frequency is inversely proportional to wavelength. So frequency is inversely proportional to wavelength. Okay. So high frequency means short lambda. High frequency, short lambda, so difficult to diffract. Remember just now we learned that with high frequency, lambda is shorter, so difficult to diffract. Only C can hear, so only C can hear the sound. But when we use low frequency sound wave, it will produce long lambda. So long lambda, sound easily diffracted when long lambda, so all 3 students can hear. So the sound can move here after here. Okay, it's distributed until it comes to student A, so A can hear. Student A, B can hear the sound. Okay, next question. Owls berantu are able to communicate across long distance in the forest because they have long wavelength roots. Explain. Yes. So the sound of the two owls, the sound of the owls will diffract through the space between trees in the forest. Remember, forests have many trees, right? So it will produce like the gaps and space. The longer the wavelength of the hood, also easier to be diffracted. So longer wavelength means easy to be diffracted and it can move long distance. Okay. And last question, infrasonic wave produced by elephant have long wavelength to facilitate long distance communication between elephants. Remember, long wavelength sound can be diffracted easily and it can move further without any distraction. Okay, so that's the end of topic 5.3, diffraction of wave. So see you next time. Thank you. Bye. Assalamualaikum.